Hello and welcome to EGM722, Week 1, Part 1, Why Programming. So this week we're going to go through a brief introduction to programming using Python, and in the next lessons we will talk about built-in types in Python, how we can control flow in our programs, how we can use functions to help make them more readable, and finally we'll talk about Git in a brief introduction. So, why programming? Well, in GIS and remote sensing, we're often repeating the same tasks over and over again. We might be processing new data or new data for different areas, and these tasks often form some kind of a workflow. So what happens if we need to redo a single step that comes right in the middle or in the beginning of our workflow, upon which all of the rest of the workflow depends? What happens if someone else needs to do the exact same steps that you did on a different computer and you're not there to show them how you did it? What happens if we're lazy and we don't want to do the same tasks over and over again? Well, it turns out that computers are really, really good at repeating the same tasks over and 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 so on. But for now, we have to actually give them instructions to get them to do those tasks. And that process of giving computers instructions in order for them to do tasks over and over again is something that we call programming. So we're going to be using Python in this course, or in this module, because Python is probably the most prolific language in terms of GIS and remote sensing, partly because of the history of the development of Python alongside of software like ArcMap and others. So we're going to be sticking with Python just because it has a lot of applications within GIS that we can make use of. So Python is an interpreted high-level language. Now what this means, I'll talk about what interpreted means in a minute, but high-level means that it's something that is made more for people to read as opposed to for computers to read. It is interpreted in that the computer actually has to take the code, translate it into something that the computer can then read before it runs it. So that program that does that is known as the Python interpreter. So the interpreter, again, reads the code, translates it into something that the machine can read and use, and then executes the code or runs it. We can use Python in two different ways. We can either do it in interactive mode, where we have a shell open and we are typing out different commands as we go, or we can run it in script mode, which is where we have a file called a script, where we have written out a series of instructions for the program, for the computer to follow, that we can then run and have the computer go through each of those steps one by one without us having to tell it to do so as we would in the interactive mode. So Python is an object-oriented programming language, which is to say that all of the things that Python is working with, or that we are working with within Python, are known as objects. Objects have a number of different properties, including type, so that is to say what kind of object it is. You can see some examples here where we have strings, which are text. We have integers, we have floating point numbers, we have something called a tuple that we'll talk about in the next lesson. And again, we have something called strings. So we have lots of different built-in objects that we'll talk about, and then there are also many, many different types of objects that have been created by people writing Python code. Objects also have properties that we can access or use, or that the Python interpreter can use to run the programs, and they also have something called methods that we'll talk about later this week. Variables in Python, like in other programming languages, are something that refers to an object. In Python, a variable is a name that refers to a particular object. For example, here we have a message that we've written out. It is a text string, and it has the name message. We have another variable called n, and we can see that they have different classes or different types, just like what we saw when we were looking at types on the previous slide. You can think of variables as a box in the computer's memory where you store a single value, and that comes from the Automate the Boring Stuff with Python textbook that is recommended for this module. If we want to actually save the values that we're using to be able to use them later, then we have to actually store them in a variable. We can't type something into the interpreter and then expect that the computer is going to hold that in memory for us. We need to actually tell it to store it in memory and tell it what to store it or what name to give it so that we can access it later on. When we create variables, we are using something called an assignment statement. So this example here, where we have message and then there's an equal sign, the parrot is pining for the fjords, that is an assignment statement. We are taking the string, the parrot is pining for the fjords, and we are assigning it to a variable called message. And I want to be very clear about this. In programming in Python and in a lot of other languages, the equal sign does not actually mean equal to. So don't think about this like message equals the parrot is pining for the fjords. Think of this as the variable called message is being given a value of whatever is on the right-hand side, or if you prefer, everything on the right-hand side is being assigned to a variable called whatever is on the left-hand side. When we're naming variables, there are a number of good practices that we can keep in mind. The first is that we should choose meaningful names for our variables, which is to say that we're not going to name things like variable 1, variable 2, variable 3, and on down the line. Instead, we're going to choose something that actually tells us what the variable is or what it does, so that when we or when someone else comes back and reads our code later, they have an easier time understanding what is going on. We also want to make sure that our names for variables begin with a letter. They can begin with a letter or an underscore, but they cannot begin with things like numbers or other characters. Variable names can also contain underscores. These are usually used to indicate spaces. There are some other uses for them that we will talk about a little bit as the module goes on, but for now just think of them as something that replaces a space. Bad practices when we're naming our variables, well, the first one is that we can't use illegal characters, so things like the @ symbol or the ampersand, exclamation points, none of those things can be used in variable names. We also cannot use protected keywords. So these are words like and or for or if, and there's a number of other ones. Again, we'll talk more about these as the week goes on. But these are things that Python has to use for certain operations. And if we replace it, or if we try to replace it with a variable name, it's going to throw an error. We also try not to overwrite built-in types or classes. We'll talk again more about this in the next lessons, but things like list or int, these are built-in Python types, and if you assign a variable to this name, it will overwrite that type in your program and you won't be able to use it later. So good practice is to avoid using built-in types or class names for our variable names. So when we're doing computations or working with variables in Python, we're often going to be using something called an operator. So these are, most often we'll see these with arithmetic, but you use operators for other functions as well. Some different examples that we'll see here. The first is addition with the plus sign. If we're using strings or lists, this is actually concatenation, which is something that we'll talk about in the slides to come. To do subtraction, we're using the minus sign. Multiplication is done using the asterisk symbol, but again, this operator also works for strings and lists, though it does something a little bit different. For division, we use the / symbol, and in Python 3, which is what we will be working with in this module, we're using, or in Python 3, which is what we are using in this module, the division that is returned by this operator is normal division. It's what you would expect to happen if you say divide 4 divided by 5, you get 0.8 back. In Python 2, this defaulted to something called floor division, where it, instead of giving a floating point number back, it gives an integer value back, and it just truncates the result before the decimal point. So if you have something like 4 divided by 5 or 1 divided by 3, the result is going to be 0. For the most part, Python 2 is gone. It's no longer supported as of the 1st of January 2020. If you're using ArcMap, so ArcGIS 10 point whatever, the Python version that ships with is still Python 2. If you're using ArcGIS Pro, they have upgraded to Python 3, so you don't have to worry about this anymore. If we want to do exponentiation, we have 2 asterisk symbols together. Keep in mind that the caret symbol is actually a separate operator. It's the function for that operator is not something that we're going to necessarily get into in this module, but you're welcome to go look that up and see what it does. Because if you get further into computer programming, this sort of operation can become important. And then finally, another one that we might see in some examples is something called modular arithmetic, and that is done with a % symbol. So Python follows the order of operations, and specifically the PEMDAS or PEMDAS, which stands for parentheses. So anything in parentheses is executed first, followed by exponents, followed by multiplication and division, followed by addition and subtraction. Operators that have the same precedence, so multiplication and division, or addition and subtraction, are evaluated from left to right. So we're following this order of operations, but if we have multiple operators of the same type, so multiple division statements or multiple multiplication statements on the same line, then it evaluates it moving from left to right. So there's a number of examples here that you are welcome to try to work through, and you can test your expectation of the results by typing these exactly as they are into a Python interpreter and seeing what the result comes up. And hopefully you're able to work out what these are in the same way that the Python interpreter is going to. The last thing that we'll talk about is something called an expression and something called a statement. So an expression is just some combination of objects, variables, and operators. So for example, 42 is a statement. It is just a value, an integer value with the numeric value of 42. X, the variable, is also an expression, as is x plus 42. A statement, on the other hand, is a unit of code that the interpreter can actually execute or evaluate. So for example, we've seen assignment statements already where we're taking the value of 42 and we are assigning it to the variable called x. We will also see things like return statements or pass statements, and there will be plenty more that we'll look at in the next several lessons. Okay, to sum all of this up, programming is simply just giving a computer instructions in order to execute tasks. Python is one language, and the language that we will be learning in this module, that we can use in order to give a computer instructions to get it to execute tasks for us. Python uses objects in order to carry out different computations or other tasks, because again, an object-oriented programming language. So there's a number of different links here. You can find these also on the Blackboard website. The first is a link to the Automate the Boring Stuff with Python 2nd edition textbook. It's freely available online. If you want a hard copy, you're welcome to order it from the publisher as well. But the textbook at least is online from the link that you'll find. You can also find a YouTube series that goes through a lot of the lessons from the author of the textbook. There's also a number of different tutorials at learnpython.org that you can go through. Beginner's Guide to Python at python.org, which is the official website of the Python project. And then the official documentation for the version of Python that we will mostly be using for the examples, the practicals in this module is linked to here. So that's all for this lesson. I hope you found it interesting, and if you have any questions, please don't hesitate to post them to the discussion forum or email me. Thanks. Bye.